Hi guys, I told you I'd look into this, and I did, and I racked my brains to try to show you a better way to think about this. And so hopefully this video will help clear some things up. So what I think would help is if you, when you're doing this, if you put parentheses around the terms. Okay, so the minus minus A and the B plus plus, and then this is a minus minus B, and that's an A plus plus. Okay. All right, so if we look at it, we know that it takes 1 away from A. Let's say A is 3 and B is 5. So this always happens first. If it's in front, it happens right away. So A would go to 2, and then immediately, because this double is touching it, it would go to 2.0. All right, so I think everybody's got that one. And then it's added to B. So this is going to be, we're at 2.0, I'll put it here. And then we plus, and okay, so it's all about memory. This is what I looked up so it would make sense. What happens, as a matter of fact, Java puts these implicitly around these. It kind of does it itself when it's doing its compulations. But for this one, it's going to put B down first, okay, and then increment B. But it's going to put it down, like, or add it before it increments. So it would be 5. And then right away, and so I'm going to put like increment, so that you see it's still 5 for the 2.0 plus 5, but then you increment it after. So it becomes 7.0, and then you're going to increment B to 6. Okay, now you're at 7, and you have a minus, minus, minus B. So this is going to happen, the minus minus B is first, so it's going to immediately happen. So that would be 7 minus, and then we got to take 1 away from B and put it back down to 5, and that's what gets subtracted. Okay, so we're at, what is that, 2.0? And now it's going to add A. This is the A with the increment. So it's going to do 2.0 plus A, and A is at 2.0. So A becomes 3.0. But our sum, this was 2.0 plus 2.0 before I incremented it. So I should have said that. Like, I should have said this. Let me stop there. We were at 2.0. And so when I write this down, it's 2.0 plus, what's A? 2.0. But then you have to increment A to 3.0, which doesn't really make a difference in this print line. So it prints out 4.0. Okay, so that's kind of cool. All right, now let's do the other one. And the other one, I'll just tell you ahead of time. Those of you who said it was 7, it's right. And if you figured out it was 7 on your own without looking it up or doing it on the computer, you come to me, and we'll give you that point back. If you looked it up on the computer to figure it out, don't come to me, okay? It's not like you're going to get in trouble. Just don't come to me asking for points back if you didn't do it on your own. But kudos to you. I never actually, I just like got confused, I'll just admit, with this times 0 and wasn't even thinking. I'm going to do something too in a minute. I'm going to change that to a times 1. And so you can see whether or not A becomes the new A times 1 or the original A way back at the beginning. But that's a whole different problem. Okay. So here we go. I already put the parentheses around it, okay? And now, in order for this to even do anything, you needed to either assign it to a variable or do a system out print line. So anyway, I put a C here. So let's put what A is. A is 0 and B is 1. So in that same manner, what got me confused is because this is the same variable. It's the same variable. So you're like, oh no, what's happening when it's the same variable? But if you kind of do that little increment thing, it'll make sense. So, and I think that's what confused me, because I didn't have any problem doing it when it was an A and a B. But when it was A on top of itself, it was messing with A before it wrote A down. So let's keep our same procedure. We have to write A down what it is. So because this happens after. So we're going to write A, which is 0. Okay? But it's an increment. Okay? And so what happens is it's plus so what happens is it keeps the 0, but it does the increment before it's going to go on. So this would change to 1, but this isn't 1 right here. This is 0. Does that make sense? And then plus, now this happens right away. The plus would come first, so we would change it to 2, so that we have 0 plus 2. So we're at 2 here. From here to here, we're at 2. And then it's plus 6, so now we're at 8. Now, then we have a plus and we have an A. And so we write the A down. A is 2, but it's plus after, so we're going to increment it after we add this. So this would be 10, and then this would change to 3. So we're now down to here. We're at 10. Then we're going to have a minus, and in this case, we're going to have B happen first. It's going to be B, which is 1, and then an increment. So that becomes 9, and then the increment happens here to 2. Okay, so we're to here. Then am I there? That's where I am? Yeah. So then we take away B, which is 2, but it's got a decrement after I do it. So that would be 7, and that's going back to 1. So now I'm to here. And so then I have a minus. Now, this in order of operations would happen first, just by itself. This term times this term would be a subtraction. Times 0. So it's minus 0, and you get 7. Okay? So I hope that helped a little bit. I really think putting the parentheses around helps it, and doing these little increments. So you remember to increment over here, but don't increment into the actual addition or subtraction. Okay, I was telling some people at school that I think, if I gave you one of these, it wouldn't be this complicated. It would be a pretty simple problem, and I definitely wouldn't do the A on a variable of itself. That gets really confusing of when that happens. But we might all be experts by it. This might be more like an extra credit one that's that complicated. So if you have any interest in this and want to learn it real well, besides just the average, what does plus do at the beginning and what does plus do at the end, then kind of understand this. In the real world, and you can look back in the notes, it said it's not recommended that you use A++ or plus A's with operators between them for this very reason. That it's complicated. You're not the only ones that struggled with this. Everyone who does this struggles with this. I'm included in there, of course. So they just don't recommend it. They really want you to use, when you have sum equals 5, and then you want to go sum plus, and that just makes sum 6. Doing a plus is faster than doing sum equals sum plus 1. It uses less memory. It's faster compile time, putting it in a bytecode. So anyway, bottom line is it's used this way. This is sort of like them really trying to mess with your head a little bit, but also kind of fun for some people. So I'm going to do the one with 1. I'm going to change that to a 1 on the next video. So if you're interested, go to the next video and see what happens when you have this last little bit. It's trying to figure out when A, was A the new A by the time it got over here, or was A from all the way back when it was 0? Okay, so I'll talk to you later.